Yes, hello everyone, welcome. This is lecture number 6 of analytical geometry. So if you haven't watched all the previous classes, so go through all the classes and come back to this video, right? So this is the last video on planes. So already we have completed direction quotient and direction ratio in the very first three video. And the last two video we are talking about planes, and this is the last class on planes, right? So far in planes we have solved 20 problems. So in this class we want to introduce some more concept and we're going to do problems based on that also, right? Yes, so we have stopped at problem number 20 in the previous class. So first what we will do is we will do problem number 21, and then we will introduce some more concepts, right? This is somewhat similar to the one problem that we have solved earlier. So we will start, right? So I hope there will be no doubt from the previous classes. So we will start this session, and first question itself is very important question, very important question. So we will solve this. A point P. So I think we have stopped at 21st problem in the previous class, right? That means it will be 22. 22nd problem, right? Okay. So a point P moves on the plane. A point P moves on the plane x by a plus y by b plus z by c is equal to 1, which is fixed. The plane through P perpendicular to OP meets the coordinate axis in ABC respectively. The plane through ABC parallel to x, y, z, zx and xy plane intersect at Q. Prove that the locus of Q is 1 by x square plus 1 by y square plus 1 by z square is equal to 1 by ax plus 1 by by plus 1 by cz. Right? So very important problem. First we'll understand this question and then we will solve this problem. So we have a point P that moves in this plane, right? Let us draw this plane x by a. Let us draw this plane. So I'm just going to draw a very rough diagram, right? Very rough diagram. So we have a plane x by a plus y by b plus z by c is equal to 1, right? Let us call this point to be P, call this point to be Q, call this point to be R. This point is a comma 0 comma 0. This point is 0 comma b comma 0, and this point is 0 comma 0 comma c. So in this plane, a point P moves in this plane. Let us say this is our point P, right? So we have a point P that moves in this plane, right? Or let us say this is our point P, right? That is our point P. I'm just going to draw a very rough diagram, right? So that you will have some clarity when you are doing the problem. So we have point P that moves in this plane, which is x by a plus y by b plus z by c is equal to 1, which is fixed. This plane is fixed. This point is moving, right? So first we will write this first line in terms of solutions, right? So let P be the point that is moving, right? Let us call that point to be, let P be alpha, beta, gamma, be the moving point, be the moving point on the plane, on the plane x by a plus y by b plus z by c is equal to 1, right? So we have a point that is moving in the plane. Now the plane through P perpendicular to OP meets the coordinate axis in ABC. So what we are doing is we are drawing one more plane. That plane passes through P and perpendicular to OP. Right? We are drawing one more plane. That plane passes through P and perpendicular to OP. Right? I'm just going to draw very rough diagram. Right? Very rough diagram. So I'm going to draw one more plane P, right? So this plane passes through the point P. This plane passes through the point P, and also this is perpendicular to OP, right? So assume that this plane is passing, this yellow colored plane, right? This yellow colored plane is passing through P, and assume that this yellow colored plane is perpendicular to this line OP, and this plane, this yellow plane, What is yellow plane? Yellow plane is the one that is passing through P and perpendicular to OP. It meets the plane perpendicular to, sorry, the plane passing through P and perpendicular to OP meets the coordinate axis in ABC. So it meets the coordinate axis at A and B and C respectively. See, that is why only I use PQR here. Usually you write ABC, right? But I'm written PQR here as these are just coordinates, right? I'm using ABC here. Okay. So a plane through P and perpendicular to OP meets the coordinate axis in ABC respectively. Now, the plane through ABC parallel to YZ, ZX and XY plane intersect at Q. So we are drawing three more planes that is parallel to XY plane, YZ plane and ZX plane, right? So we will do that. So let us draw some planes, right? So we all learn this, right? So passing X is equal to A, Y is equal to B, Z is equal to C. Similarly, we need to draw a plane that has to pass through this A. This is a plane that is perpendicular to X, Y, Y, Z and ZX. We need to draw three more planes. This is the locus of intersection. Call this as Q. Right, so we are drawing a plane parallel to xy, yz, zx plane, right? This is our x-axis, this is our y-axis, and this is our z-axis. So we need to show the locus of this point Q. The locus of this point Q is, we need to show the locus of this point Q is 1 by x square plus 1 by y square plus 1 by z square is equal to 1 by ax plus 1 by by plus 1 by cz, right? Very easy problem. So we will do this, right? So we have two planes here. The first plane is x by a plus y by b plus z by c is equal to 1. But we don't know the equation of yellow plane. This yellow plane meets the coordinate axis in ABC, and through ABC we are drawing a parallel planes, and this will meet at some point Q. We need to show the locus of Q is this, right? Very important problem. Okay, so uh, we have assumed a point P, a moving point P on this plane, right? So that means this point will satisfy this equation. So that means alpha by A plus beta by B plus gamma by C is equal to 1. Yes or no? Because this point lies in this plane, right? Okay. Now we are going to find the equation of yellow plane. We know equation of white plane. White plane is x by a plus y by b plus z by c is equal to 1. We going to find the equation of this yellow plane. So how to find the equation of this yellow plane? Very easy, right? So you can see this yellow plane is passing through P and this yellow plane is perpendicular to OP. You know, right? Equation of plane passing through a point and perpendicular to a line. We know equation of that plane, right? Equation of plane passing through a point and perpendicular to some line which has direction ratio something. We know that equation, right? Now, to find equation of yellow plane. Now, to find equation of, and just write in layman term, right? This yellow plane is the one that is passing through P. Now we can see this yellow plane passes through P, and we know P point is alpha comma beta comma gamma. It is perpendicular to some straight line, and it is perpendicular to the straight line OP that we already given, right? It passes through P and perpendicular to OP. So what is the equation of plane passing through a point and perpendicular to a straight line OP? Now what is the direction ratio of OP? What is direction ratio of OP? So O is origin, P is alpha comma beta gamma gamma, right? O is origin. So it is nothing but x2 minus x1, y2 minus y1, z2 minus z1. So alpha minus 0, beta minus 0, gamma minus 0 is the direction ratio of OP. Now what is the equation? A into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0 is the equation where ABC is the direction ratio of the straight line which is perpendicular to that, and p x1 y1 z1 is the point that it is passing through. Now here this is our x1, this is our y1, this is our z1, and ABC is also alpha beta gamma. X1 y1 z1 is also alpha beta gamma. ABC is also alpha, beta, gamma, right? Now substitute back here. So we have alpha into x minus alpha plus beta into y minus beta plus gamma into z minus gamma is equal to 0. So we have alpha x plus beta y plus gamma z. So we have minus alpha square minus beta square minus gamma square. So take it to that side. So we have alpha square plus beta square plus gamma square. This is the equation of yellow plane. Is it clear up to now? Equation of white plane is x by a plus y by b plus z by c is equal to 1. And the equation of this yellow plane. This yellow plane is passing through P and perpendicular to OP. So we know general equation of plane. So I'm using that here x1, y1, z1, abc both are all are same only. This is the equation of yellow plane. You can see this of the form ax plus by plus cz plus d is equal to 0. Now how to find abc? Abc are the intercepts, right, of this plane, right? Yellow plane is this. If you put y is equal to 0, z is equal to 0, you can find this point. And if you put x and z are 0, you can find this point b. If you put x and y to be 0, you can find z is intercepts. I'm just going to find intercepts. Remember, this intercept is ABC, but I'm finding intercept for this ABC, not for PQR. Intercept of PQR is ABC. I'm going to find intercept for this ABC. ABC is the intercepts for yellow plane, right? Now, what is the equation of yellow plane? So we have alpha x plus beta y plus gamma z is equal to alpha square plus beta square plus gamma square is the equation of yellow plane. Now to find x intercept, you put y is equal to 0, z is equal to 0, right? Y and z are equal to 0. What you will have as x? So you will have x to be equal to, so y is 0, z is 0. So we have x is equal to, so we have x is equal to alpha square plus beta square plus gamma square divided by alpha. This is our x point. This point is 0 comma 0 comma, this point is sorry, x intercept is what? Alpha square plus beta square plus gamma square by alpha comma 0 comma 0. This is the point of A. Now similarly, to find the point B, you put x is equal to 0, z is equal to 0. So you will have y intercepts, which is alpha square plus beta square plus gamma square divided by beta. And for z intercept, you put x is equal to 0, y is equal to 0. So you will have this 2 will get cancelled. So we have z is equal to alpha square plus beta square plus gamma square divided by gamma. So these are the intercepts. Now, through intercepts, we are drawing a parallel plane. What is the equation of this blue line? Usually, this will be x is equal to a. If I draw here, we will have x is equal to a. But here we are drawing through this point. What is this point? This point is alpha square plus beta square plus gamma square by alpha. What is the equation of this blue line? X is equal to this value. Usually we will have x is equal to a if I draw here, but we are drawing here. So it passes through the point A. What is the x length? It is alpha square plus beta square plus gamma square by alpha. So through ABC we are drawing a parallel planes, right? So through ABC, through A comma B comma C, parallel planes are drawn. So what are those equations? So we have this equation is x is equal to alpha square plus beta square, alpha square plus beta square plus gamma square by alpha. Usually we will have y is equal to b, but here it passes through this point. This point is y intercept, which is alpha square plus beta square plus gamma square by beta. And z is equal to alpha square plus beta square plus gamma square by gamma. These are the equation of three parallel planes, right? These are the three equations of parallel plane. Now we have to prove these two are equal, right? These two are equal. So we will prove this. So 1 by x square plus 1. So we know x, y, z, right? So first what we'll do is we will find this separately, we will find this separately, and then we will show both are equal. So first let us take LHS part, right? Let's take LHS part. So what is LHS? First we will find the value of LHS. So it is 1 by x square plus 1 by y square plus 1 by z square. So 1 by x square. So x is this. So 1 by x square will be what? 1 by x square will be alpha square divided by alpha square plus beta square plus gamma square whole square, right? So 1 by x is reciprocate. So we will have alpha divided by alpha square plus beta square plus gamma square. Now square it down, you will have this. And similarly, what about 1 by y square? So 1 by y square will be beta square divided by alpha square plus beta square plus gamma square whole square plus 1 by z square is this. Now this will be alpha square plus beta square plus gamma square divided by alpha square plus beta square plus gamma square whole square. So these will get cancelled. So we will have 1 divided by alpha square plus beta square plus gamma square. So this is the value of LHS. Now we will do RHS. See, very simple. First, we need to find x, y, z in terms of alpha. What is alpha? Alpha is a fixed. Alpha is a point that is moving in the plane, which we have assumed alpha, beta, gamma. So this is nothing but x is equal to some point, y is equal to some point, z is equal to some point. First, we need to find intercept of this y plane. After that, we can easily find the equations. Now, what is RHS? 1 by x plus 1 by by plus 1 by cz. So 1 by x plus 1 by by plus 1 by cz. So 1 by a into 1 by x. What is 1 by x? 1 by x is alpha divided by alpha square plus beta square plus gamma square plus 1 by b into 1 by y. So 1 by y will be beta divided by alpha square plus beta square plus gamma square plus 1 by c into 1 by z. So 1 by z is gamma divided by alpha square plus beta square plus gamma square. Now, so if I take 1 divided by alpha square plus beta square plus gamma square common, we will have alpha by a plus beta by b plus gamma by c. This value is equal to 1. This value is 1, right? Because we know alpha by a plus beta by b plus gamma by c lies in this plane. We will satisfy this equation. So this will be 1 divided by alpha square plus beta square plus gamma square. So we can see both are same. So therefore, the locus of the point Q is 1 by x square. Locus of Q is this is the required locus we need to find, right? Very simple problem, slightly conceptual. Slightly conceptual. You just have to understand this. See, very simple. You just have to find this equation. This is x is equal to something. This is y is equal to something. Z is equal to something. Right? This something is the point that it is passing through. So first you find equation of yellow plane using the concept that it is passing through P and perpendicular to OP. After that, very easy to find x intercept, y intercept, z intercept. Put y and z to be 0, you will get x intercept. So you will have x, y, z intercept. And we know equation of parallel plane is x is equal to a, y is equal to b, z is equal to c. A, B, C is known that it is passing through. So you will get these three equation. After that, you just have to, x, y, z. Find this substitute x, y, z there. You will be proved. Okay. See, this is a previous year's question. It is not beyond the level of UPSC. This question was asked in IFOS. Okay. See, it is standard problem only. Everything is in textbook. They are not asking somewhere in the own. Everything is in textbook. Everything is standard problem only. Okay. Okay. Note. So what this note says is very important note. Uh, okay. If A1, B1, C1 and A2, B2, C2 are direction ratio of some two lines, right? if A1 B1 C1, A2 B2 C2 are direction ratio of two line, what is cos theta? What is cos theta? We know, right? What is cos theta? Cos theta is A1 A2 plus B1 B2 plus C1 C2 divided by root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. This we already know. Now what you want to do is to find tan theta. That is, if you know cos theta, how to find tan theta. Cos theta is the angle between two lines in terms of direction ratio, which is A1 A2 plus B1 B2 plus C1 C2 by this, right? Now we're going to find tan theta, right? So I'm going to directly write it down how to find the value of tan theta. See, you can use the relation, right? Secant square theta minus tan square theta is 1. From that you can find tan square theta. But you just remember this formula. If you want to find tan theta, if you know cos theta, from cos theta, if you want to find tan theta, make use of this, right? So what you have to do is, now what is direction ratio of first line? It is A1 B1 C1. Now what is direction ratio of second line? It is A2 B2 C2, right? Now how to find tan theta from in terms of direction ratio, right? What you have to do is, so first write this here, right? So first start with B1 B1 C1 A1 B1, right? And similarly B2 C2 B2 C2 A2 B2, right? So write it down here. So we have tan theta is equal to square root of, see, this one minus this one. So it will be B1 C2 minus B2 C1 whole square. Let's square it down. Plus, right? Now C1 A2 minus C2 A1 whole square plus A1 B2 minus A2 B1 whole square whole divided by A1 A2 plus B1 B2 plus C1 C2. Right? This is the formula to find tan theta. Right? So cos theta is, if you know DC, just one second, one beta will be. See, this is the very important concept, that if you know direction ratio of two line and if you know cos theta, tan theta will be given by this formula, right? So how to remember this? Write this as cross multiplication method. You put square root this minus this whole square, this minus this whole square, this minus this whole square divided by A1 A2 plus B1 B2 plus C1 C2, right? You can how this came is secant square theta minus tan square theta is 1, right? Secant square theta minus tan square theta is 1. That means secant square theta minus 1 is equal to tan square theta. And you know secant square theta is 1 by cos square theta minus 1 is equal to tan square theta. So you know cos theta, substitute this cos theta here, square it and simplify it, you will get tan theta like this. But no problem, you just memorize this, right? Okay. Now we're going to move on to very interesting problem. This question is haven't asked in any IAS or IFOS, but we can expect this question. So very interesting problem. Okay. This problem number 23. A plane meets a set of three mutually perpendicular planes in the sides of a triangle whose angles are ABC respectively. Show that the first plane makes with the other plane angles the square of whose cosines are cot B, cot C, cot C, cot A, cot A, cot B. Right? When you read it, it seems to be very uneasy to follow. But if you make a diagrammatic representation, then this will be very easy. Okay, so we have a plane. A plane meets a set of three mutually perpendicular plane. Let's assume three mutually perpendicular plane B. So let three let us assume three mutually perpendicular planes. Let us assume the axis to be mutually perpendicular plane, because we know x, y, z axis are always mutually perpendicular, right? So let us assume three mutually perpendicular planes. B, x is equal to 0, y is equal to 0, z is equal to 0. So we have three mutually perpendicular planes now, right? Yes. This is the three mutually perpendicular planes. This x, this is y, this is z. This x is equal to 0, y is equal to 0, z is equal to 0. A plane, we have a plane that meets a set of three mutually perpendicular plane, the sides of a triangle whose angles are ABC. So we have a plane that meets these three mutually perpendicular planes, right? Mutually perpendicular plane, the sides of triangle, and it makes an angle ABC respectively. So this makes an angle A, this makes an angle B, and this makes an angle C, right? C respectively. Show that the first plane makes with other plane angles the square of whose cosines are cot B, cot C, cot C, cot A, cot A, cot B. Very simple, right? See, we have three planes, right? We have three planes, which is perpendicular plane. This is the first plane, right? This is the first plane. Now, what is the second plane? Second plane is this plane. And third plane is this is the third plane, right? Now, you need to find angle between the first plane, which is what is first plane, x is equal to 0, and and this big plane, right? And this big plane, this is x is equal to 0. So first you need to find angle between this yellow and the big plane, that is yellow plane, white plane. White plane is this whole plane, right? So let us take. So let um. So what we need to prove, right? What we need to prove. So let first we need to prove three things, right? So let alpha be the angle. Let alpha be the angle between x is equal to 0 and the big plane. What is a big plane? X by a plus y by b plus z by c is equal to 1. Right? Now we need to show we can find cos alpha with this, right? What is cos alpha? It is nothing but angle between the two planes. Now we need to show you find cos alpha and that you square it, right? That will be equal to either one of these three. It can be equal to cot B, cot C, or cot C, cot A, or cot A, cot B. So we need to show it is equal to cot B, cot C, or cot C, cot A, or cot A, cot B. Right? It will fall in any one of this. And similarly, let beta be the angle. Let let beta be the angle between y is equal to 0 and the plane. Now you find cos beta. After that, you square it. You need to show that it is equal to one of these three. Right? One of these three. And similarly, let gamma be the Let gamma be the angle between z is equal to 0 and the plane. So we need to show cos square gamma is either one of these three. Right? Understand the question? So we need to show cos square alpha is any one of these three and cos square beta. Now I'll read the question once again. A plane meets the three mutually perpendicular planes in the sides of a triangle whose angles are ABC respectively. Whether the first plane makes with the other plane angle the square of cosine or these three, right? See, you can easily find cos alpha, cos beta, cos gamma very easily because we know direction ratio of this plane which is 1 comma 0 comma 0 and direction ratio of this is 1 by a, 1 by b, 1 by c. You can easily find cos alpha. Cos alpha is a1 a2 plus b1 b2 plus c1 c2. So we can easily find cos alpha, cos beta, cos gamma. But how to find this cot a, cot b, cot c? That is what the trick is, right? First we will find cot A, cot B, cot C. After that we will find cos square alpha and we show that it is equal to one of these. But first we need to find cot A, cot B, cot C, right? So first we will find cot A, cot B, cot C, right? So first we will find these three things, right? Now, now what is A? A is the, let us call this as P, call this as Q, call this as R, right? Now A is the angle between PQ and PR, right? A is the angle between A is the angle between PQ and PR, right? A is the angle between PQ and PR. Now what is this P point? This P point is A comma 0 comma 0 and this is 0 comma B comma 0 and this is 0 comma 0 comma C. Now what is direction ratio of PQ? What is direction ratio of PR? Now what is direction ratio of PQ? It is nothing but x2 minus x1, y2 minus y1, z2 minus z1. So PQ. So 0 minus a, b minus 0, 0 minus 0. So minus a comma b comma 0. Minus a comma b comma 0 is the direction ratio of PQ. Now what is direction ratio of PR? What is direction ratio of PR? x2 minus x1, y2 minus y1, z2 minus z1. 0 minus a, 0 minus 0, c minus 0. So it will be minus a, 0, c. Is it clear? Now you find cos theta. You can find tan theta, right? Because we know how to find tan theta if you know direction ratio of two line, right? Now what is tan A? A is the angle between them. So what is tan A? So how to find tan A? You write direction ratio in this order. So B 0 minus AB 0 C minus A 0, right? So tan A will be square root of BC minus 0 whole square plus 0 plus AC whole square 0 plus AB whole square divided by A1 A2 plus B1 B2 plus C1 C2. So A1 A2 is A square, B1 B2 is 0, C1 C2 is 0. Is it clear? See, I'm just applying this formula. If these two are the direction ratio, then tan theta. So you can see if two line has direction ratio, then tan theta will be given by this formula. The only difference is instead of A1, B1, C1, A2, B2, C2, we have some other direction ratio, but I am having the same concept. B0 minus AB, 0C minus A0 divided by A1, A2 plus B1, B2 plus C1, C2. So we have tan A is equal to square root of AB whole square plus BC whole square plus CA whole square divided by A square. So what about if tan A is this, what is cot A? Cot A is reciprocal of this. So we have found cot A. So cot A is A square divided by AB whole square plus BC whole square plus CA whole square. Similarly, you need to find cot B and cot C. I'll find cot B, you find cot C. Now, what is, um, let B be the angle between, so let B be the angle, let B be the angle between QP and QR. QP and QR. QP and QR. Now, what is direction ratio of QP? So, it is P minus Q. So, it will be P minus Q. A minus 0, 0 minus B, 0 minus 0. So, it will be A minus B, 0. A minus B, 0 is the direction ratio of QP. And similarly, you find direction ratio of QR. So, QR, R minus Q. So, 0 minus 0. So, 0 minus BC. 0 minus BC. Now, you know direction ratio of two line. So, what about tan B? Square root of, so just have to write it in this order. Minus B 0, A minus B minus B, C 0 minus B. So, it will be minus BC minus 0 whole square minus AC whole square minus AB whole square divided by A1 A2 0 plus B1 B2 plus C1 C2. So, we have tan B is equal to square root of AB whole square plus BC whole square plus CA whole square divided by B square. This implies the value of cot B will be B divided by square root of AB whole square, BC whole square, CA whole square. Right now, similarly, let C be the angle between, what is C? C is the angle between RQ and RP. RQ and RP. Now find direction ratio, find direction ratio. You will have cot C to be equal to C square divided by square root of AB whole square, BC whole square, CA whole square, right? So we have found cot A, cot B, cot C. So what is our aim? Very simple. We need to find angle between this plane and this plane, and we need to square it up. We need to show it falls under any one of these three. But we don't know cot A, cot B, cot C, which we have easily found. Now let us take, now let us prove one by one, right? Now alpha be the angle between, now alpha is the angle between the first plane and the plane and the whole plane, which is x by a plus y by b plus z by c minus 1 is equal to 0. Now what is direction ratio of this? It is 1 comma 0 comma 0. Now what is direction ratio of this? It is 1 by a, 1 by b, 1 by c. Now alpha is the angle between them. Now you find cos alpha, right? Now you find cos alpha. So cos alpha a1 a2 plus b1 b2 plus c1 c2 divided by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. So you have cos alpha is equal to 1 by a into 1 divided by root of 1 by a square, 1 by b square, 1 by c square. Now what about cos square alpha? So it will be 1 by a square. This root will get cancelled. So we have 1 by a square plus 1 by b square plus 1 by c square. Now you take ab square LCM, right? Sorry, a square, b square, c square LCM. So we will have 1 by a square. So here already we have a square. Let us multiply b square c square. Here we already have b square. Let us multiply a square c square. And here you already have c square. Let us multiply a square b square divided by a square b square c square. This is cos square alpha. Oh, sorry. It is 1 divided by. So 1 divided by, so square root will be 1 by a square plus 1 by b square plus 1 by c square. Right? 1 divided by this. Now this will be 1 by a square. Now you take LCM here. LCM is a square b square c square. And take the two numerator divided by, here a square is there, bc is missing. So this is bc whole square. Here b square is there, ab is missing. And here ac. This will be ab whole square. Now a square will get cancelled. So we have b square c square divided by bc whole square plus ac whole square plus ab whole square, right? Now you can see b square by this is what? B square by this is what? B square by this is root. Okay, so we have a square plus b square plus c square, right? I think something is missing. We need to show square of this alpha is cot b cot c. Yes, correct only. Correct only. So I can write this as b square divided by root of ab whole square plus bc whole square plus ca whole square into c square divided by root of ab whole square plus bc whole square plus ca whole square. Both are same only, right? B square c square divided by this root will get vanished. So we will have this term. Now what is this term? This term is b square by this. This is cot b, this is cot c. So we have proved cos square alpha is cot b cot c. Now similarly you need to prove cos square beta and cos square gamma. This, right? I think you can easily do this. I'll do only one part. Now let beta be the angle between y is equal to 0 and the plane x by a plus y by b plus z by c is equal to 1. So this has direction ratio 0 comma 1 comma 0 and this has direction ratio 1 by a, 1 by b, 1 by c. So find cos theta. So it is a1 a2 plus b1 b2 by c1 0 divided by root of a1 square b1 square c1 square. So we will have 1 by a square plus 1 by b square plus 1 by c square. Now cos square beta will be 1 by b square by a square plus 1 by b square plus 1 by c square. Now take LCM. LCM is a square b square c square. This will be a square is there, bc is missing. This will be ac whole square plus ab whole square. This b square will get cancelled. So we will have a square divided by root of ab whole square plus BC whole square plus CA whole square into C square divided by root of AB whole square plus BC whole square plus CA whole square. This is cot A, this is cot C. So we have proved cos square beta is this. And similarly, you prove that cot square gamma will be cot A, cot B. Right? Very easy problem. So first you need to understand the question, then it is very easy. So first find cot A, cot B, cot C. So we know how to find tan theta. We know how to find tan theta if you know direction ratio of uh, two lines. So we need to prove this. We can easily find cos alpha, but we don't know what is cot A, cot B, cot C. So first find cot A, cot B, cot C. After that you find cos alpha and you prove that it's equal to cot B, cot C. Very easy problem. Okay. So we'll move on to next concept. So we're going to do two more concepts still left in planes. We'll do that, right? We'll have a 2 minutes break and then we'll continue. Okay. So first what we're going to do is the next concept is very important concept, again very easy concept. So we're going to find the equation of plane. That plane has to bisect the angle between two given plane, right? We already solved some problems like find the equation of plane passing through line of intersection, but it is different. It has to bisect the angle between the two planes, right? So find the equation of plane bisecting the angles between two given plane. So let us take two given plane, right? Let us take P1 to the first plane, which is A1x plus B1y plus C1z plus D1 is equal to 0. Let us take second plane P2, A2x plus B2y plus C2z plus D2 is equal to 0. We need to find equation of plane bisecting the angles between two plane, right? For very rough diagram, I will draw two plane to be this, right? Let us say this is our first plane, this is our second plane, right? Very rough diagram. Now we need to find an equation of plane that bisects the angle between two given plane. So you can see we can form two planes like this. We can form two plane like this. The first plane is this is the first plane, right? This is the first plane. So you can see, let's call this as B1. This is the first plane which bisects this angle, right? Now similarly, you can draw one more plane also. What is that one more plane? You can see what is one more plane? One more plane is this, right? So you can form you can find two planes that bisects the angle between two given plane. One will bisect at acute angle, the other will bisect at obtuse angle, right? One will bisect at acute angle, the other will bisect at obtuse angle, right? One will at acute angle, the other will at obtuse angle. So you can always form two bisecting planes. One will bisect acute angle, the other will bisect obtuse angle, right? That is why equation of planes bisecting the angles, because two angle acute obtuse, planes because b1 b2 between two given plane. You just have to understand this grammatical, then it will be easy to follow mathematics point of view. Planes means there should be two, angles means there should be two. So we will have acute angle, one is obtuse angle, right? So we will have two plane. Now what is the equation of b1 and b2, right? What is the equation of b1 and b2? That it is given by the equations of the bisecting plane, the equation of bisecting planes. See, remember these are all planes, right? Just for understanding, I have drawn you this is a line. All these are planes only, right? Just for understanding, I'm drawing this line. The equations of bisecting planes are given by, so we will have b1 and b2, right? So the b1 equation is, the b1 equation is a1x plus b1y plus c1z plus d1 divided by square root of a1 square b1 square c1 square is equal to second plane a2x plus b2y plus c2z plus d2 divided by root of a2 square b2 square c2 square. So you just have to divide by its direction ratio square root, right? You will get the equation of b1, and similarly b2 equation will be given by, b2 is nothing but minus of that, right? So we will have b1 b2 to be equal to a1x. See, if this is y is equal to x, this is y is equal to minus x. That is the equation of this line, right? This y is equal to x, this y is equal to minus x. That means if this is this, the other will be minus of that. So that means this will be a1x plus b1y plus c1z plus d1 divided by root of a1 square plus b1 square plus c1 square minus of this term a2x plus b2y plus c2z plus d2 divided by root of a2 square plus b2 square plus c2 square. Very easy concept, right? So equation of b1 and b2 is given by, you just write the plane and divide by its magnitude, and you just write the plane and divide by its. This is the formula for b1 and b2. This is the equation of b1 and b2. Now next question is whether this b1 bisect this plane acute angle or obtuse angle. If one bisects in acute angle means other will bisect at obtuse angle. Now, whether which plane bisects acute angle and which plane bisects acute angle. This is a second question. See, we have B1 here. We have B1 here and B1. Now, what is the angle between B1 and B1? If it is less than 90 means it will be acute angle. If it is 90 to 180 means it will be obtuse angle. So, how to check whether this B1 bisects at acute angle or obtuse angle? And you can repeat, can you get, and can you just visualize this, right? Which plane bisects acute angle, obtuse angle? That is the next second question, right? Now, which plane, if you are required to find, if we are if we are required if we are required to find if you are required to find which of these two bisecting planes b1 and b2, b1 and b2 represents the plane bisecting the acute angle or obtuse angle between the plane P1 and P2. See, very simple. You need to which plane bisects acute angle, whether B1 P1, whether this is acute angle or obtuse angle, we don't know. Similarly, P1 P2, we don't know. And similarly, with P2, whether this B1 and P2 acute angle, we don't know. Whether it is obtuse angle, we don't know. That is what we're going to find. Whether the angle between B1, P1, right? So we have bisecting plane P1, B1. Now, whether it bisects P1 and P2 with acute or obtuse, we don't know. And similarly, we have second bisecting plane. Whether it bisects acute or obtuse, we don't know. We're going to find the procedure now. We have two bisecting plane. Whether B1 bisects P1 in acute or obtuse, we don't know. And similarly, B1 with P2, okay, second plane, bisects acute or obtuse, we don't know. And similarly, we have one more bisecting plane, B2. Now, B2 with P1, B2 with P2. Whether it bisects acute or obtuse, we don't know. That is what we're going to find. Is it clear? See, this is very important. You just have to understand this, and it is very easy. See, we have two bisecting plane, and we have two more given plane. Now you find angle between B1 P1, but we don't know whether acute or obtuse. And B1 P2, B2 P1, we can have four possible combinations. They will ask which plane bisect acute angle. We need to do like that, right? Okay. So I'll give the procedure. So to find acute angle, for example, let us take B1 and P1, right? I'll give an example and then we will do problems. So whether we need to I'll erase in all these angles. So we have P1, right? Now this is the angle between P1 and P1. Now this is whether acute or obtuse. We don't know. So how to find, right? And similarly, B1 with P2, acute or obtuse, we don't know. And similarly, B2 with P1, acute or obtuse, we don't know. And B2 with P2. So we have four possible combinations. Now, how to find whether this angle is acute or obtuse? Let us take B1 and P1 be two planes, right? Let us take B1 and P1. So you already know the equation of B1 and you already know the equation of P1. Yes or no? P1 is the plane that is already given. And the B1 is the one which you already found using this formula. That means you know the equation of two planes in general form. That means you know direction ratio also, right? You know direction ratio also. Let us say this direction ratio is sum A1, B1, C1. Let us say this direction ratio is sum A2, B2, C2. Now find cos theta, right? Now find cos theta, right? Now find cos theta, that is angle between these two planes, which is A1, A2 plus B1, B2 plus C1, C2 divided by root of A1 square plus B1 square plus C1 square into root of A2 square, B2 square, C2 square. Now after this cos theta, you need to find the value of tan theta, right? Now find tan theta. This is the step 1. Now step 2 is find tan theta using this formula. So tan theta is equal to square root of secant square theta minus 1, right? Because we know secant square theta minus tan square theta is 1. So that means tan square theta is secant square theta minus 1. Tan theta is root of this. Now you already know cos theta value, right? Substitute back here. This will be 1 divided by cos square theta minus 1. You already found the value of cos theta. Substitute back here, right? Now step 3. If the value of this is less than 1, if tan theta is less than 1 means it will bisect at acute angle. It will bisect at acute angle. If tan theta greater than 1 means it will bisect at obtuse angle. Right? Very easy. So if they ask you to find which bisecting plane bisect acute angle means, you just take the first bisecting plane and you take P1 and find tan theta. If it is less than 1 means you say it bisected acute angle. If it is greater than 1 means you say it bisected obtuse angle. Right? So we'll do problem that will be easy for you to follow. Okay. Now 24. And before that, one more note. This note 1. Note 2 is note 2 is the condition for origin to lie in acute angle between the plane is A1 A2 plus B1 B2 plus C1 C2 is negative. Condition for the condition for origin to lie in obtuse angle between planes is A1 A2 plus B1 B2 plus C1 C2 is positive. Very easy. So this will be acute angle or obtuse angle. Origin will be here if this happens. The condition for origin will be in acute angle if this happens. Origin will be in the obtuse angle. That is, origin will be in between these two plane. In between these two plane, if that happens, very simple. Origin will be in acute angle if this happens. Origin will be in obtuse angle if this happens. Very simple, right? Okay. So we'll move on to problems. Okay. Number 24. Find the equation of the bisectors of. Find the equation of bisectors of the angle between the plane of the angle between the planes 2x minus y minus 2z minus 6 equal to 0 and 3x plus 2y minus 6z minus 12 is equal to 0 and distinguish them. This will be a question, right? So find the equation of bisectors of the angle between the plane and distinguish them. That means we need to distinguish means we need to say which bisecting plane bisect acute angle, obtuse angle and so on, right? Okay. So they are given two planes, right? P1 and P2. Now we will find the equation of bisecting plane. So they are given P1 and P2. Now we will find B1 and B2. Now what is first bisecting plane? So it is 2x minus y minus 2z minus 6 divided by square root of 4 plus 1 plus 4 is equal to 3x plus 2y minus 6z minus 12 divided by square root of 9 plus 4 plus 36. So 2x minus y minus 2z divided by 3 is equal to 3x plus 2y minus 6z minus 12 divided by 7. So cross multiply this. So we will have 7 2s are 14. So we will have 14x minus 7y minus 14z minus 42 is equal to 9x plus 6y minus 18z minus 36. So 14 minus 9 is 5x minus 13y plus 4z minus 42 plus 36. So this is the equation of first bisecting plane, which is 5x minus 13y plus 4z minus 6 is equal to 0. And similarly, you find equation of second bisecting plane. So it is 2x minus y minus 2z minus 6 divided by root of 4 plus 1 plus 4. The only thing is here you have minus. Minus 3x plus 2y minus 6z minus 12 divided by root of 49, right? So we have, this will be 7. So we will have 14x minus 7y minus 14z minus 42. Only thing is here you have minus, this will be 3. So we will have minus 9x minus 6y plus 3. 3 these are 9, 6 plus 18z minus not plus 36. So 14x minus 14x plus 9x, this will be 23x minus 7y plus 6y. So minus y minus 14z minus 18z. So it will be minus 32z minus 42 minus 36. So minus 48 minus 78 is equal to 0. This is the equation of second bisecting plane, right? 23x minus y minus 32z minus 78 is equal to 0. Is it clear up to now? See, to find b1 and b2, it is very easy. You just have to divide by its root of a square b square c square. Here we will have minus here. So we have found b1 and b2. Now we need to find distinguish between them. So let us, this is our b1. Right now, what we will do is we will distinguish means you need to tell which bisect acute angle, obtuse angle, and so on. Okay. So first, what we'll do is we will find angle between P1 and P1. That is, we will find tan theta between B1 and P1, right? Okay. angle between B1 and P1. Now what is direction ratio of B1? What is direction ratio of B1? 5 minus 13, 4, right? 5 minus 13, 4. Now what is direction ratio of the first plane? Direction ratio of first plane is 2 minus 1, 2. 2 minus 1 minus 2. So find cos theta A1, A2 plus B1, B2 plus C1, C2 divided by root of A square plus B square plus C square into root of A square plus B square plus C square. So you will have cos theta is equal to 13 minus 8 is 5. 5 divided by 169 plus 16 is 185. 185 plus 25, that will be root 210. Right? This is the value. Sorry, root 210 into 3 because this is root 9. So 5 divided by 3 root 210 is the value of cos theta, right? Okay, it is not 23 minus 8, this is 15, sorry. So 3 ones are 3 fives are. So you will have cos theta is equal to 5 divided by root 10, right? Now you need to find tan theta. Now what is tan theta? Now tan theta is equal to square root of secant square theta minus 1. So this will be square root of, now what is secant square theta? So cos square theta is 25. This implies secant theta is root 210 by 5. Secant square will be 210 by 25 minus 1. So this will be square root of 210 minus 25. 200, 185, right? So 185 by 25. So this will be root of 185 by 5. Surely it will be greater than 1, right? Because root 185 is somewhere around uh, root 144 is 12, root 169 is 13. So this will be around 14 by 5 something. So 14 point something by 5, which will always be greater than 1. That means what? Tan theta is greater than 1. That means if tan theta is greater than 1, it will bisect at obtuse angle. That means B1 and P1 bisects at obtuse angle. That's it, right? It bisected obtuse angle, right? If B1, that is B1 bisects at obtuse angle. B1 bisects at obtuse angle. If B1 bisects at obtuse angle, then surely what about B2? B2 will bisect at obtuse angle, right? That's it. So you need to show which plane bisect acute angle, which plane bisect obtuse angle. You just find any one angle. If one is acute, other will be obtuse. If one is obtuse, other will be acute. Right? Is it clear? And where origin lies? Where origin lies? Origin lies in where? And where origin lies? In acute angle or obtuse angle? You just find the value of A1, A2 plus B1, B2 plus C1, C2. Now what is A1, A2? This is A1, B1, C1, A2, B2, C2. So 6 minus 2 will be 6 minus 2 plus 12, right? 6 minus 2 plus 12, which is positive. That means, or if A1, A2 plus B1, B2 plus C1, C2 is positive, means origin lies in obtuse angle. So distinguish means you need to do these three things. Which plane bisect acute angle, which plane bisect obtuse angle, and where origin lies. You need to do three things. Right? Okay. I think one problem is enough. In the practice questions, I'll give you more problems, right? See, because this one problem is enough to do any problem. If they change the questions, you can do, right. Instead of 2 minus 1, 2 minus 6, 3, 2 minus 6, 12, you can do any question, right? This is the procedure. You find B1 and B2, which is very easy, and find angle between B1 and P1. If one is acute, other is obtuse. If B1 turns out to be obtuse, you say B1 bisect obtuse angle, and B2 will bisect obtuse. Just a minute, just a minute. This acute angle. Sorry. See, if one is obtuse, other will be acute. Sorry. If one is obtuse, other will be acute only. Right? Yes. So B1 bisects at obtuse angle, which we already found, right? Because tan theta is greater than 1. Right? That means it will be obtuse. So that means B2 will be acute. Right? If tan theta turns out to be less than 1 means you say it is acute. The other will be obtuse. Right? Okay. So if they will say find the equation of bisectors of angle between the plane means you find B1 and B2, and distinguish them means you need to say whether B1 bisect acute or obtuse. You just find B1 and P1, find tan theta. If it is greater than 1 means you say B1 bisect obtuse, the other B2 will bisect acute. And where origin lies, you find value of a1 a2 plus b1 b2 plus c1 c2. If it is positive means origin lies in obtuse angle. If it is negative means origin lies in acute angle. Right? We'll move on to next concept. Is it clear, right? Okay, so we'll move on to last concept and then we'll wind up. The last concept is equation of pair of planes. We'll move on to the last concept. So I will give some practice problem from this concept also. So combine the equation of pair of plane, right? Just a minute. See, we have this is the general homogeneous equation of second degree, right? Ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy is the equation of um, second degree. Now you can see when you multiply two plane, it will be like this only, right? Ax plus by plus cz plus d is one plane. Another plane b a2x plus b2y plus c2z plus d2 is equal to 0. Now if you multiply two plane, right? You multiply ax plus a1x plus b1y plus c1z plus d1. If you multiply one more plane a2x plus b2y plus c2z plus d2 is equal to 0. So a1 a2 x square. Just forget about the coefficients. It will be in this pattern only, right? X square xy term, and this is the general homogeneous equation of second degree. This will represent the pair of plane if the following condition satisfied, right? This is the multiplication of two plane if the following condition is satisfied. If this happens, that is, if the determinant of is 0, right? If this determinant is 0, then this will represent a pair of plane. Very important, right? So the second degree general homogeneous equation of second degree, which is ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy plus c will represent a pair of plane if this happens, right? That is, this is the multiplication of two plane if this happens. How to find angle between them, right? See, remember, we don't know what are those two planes are. We only know the product of the two planes. Is it clear? We don't know the individual planes, but this will represent a product of two planes if this happens, but we don't know what are those individual planes are. If I know individual plane means I can easily find angle between them. Direction ratio of first plane, direction ratio of second plane, and so on. But here we have only one equation of second degree. We don't know individual planes. Now how to find angle between them? That is the next question. Now to find angle between them, to find angle between them, right? So to find angle between them. So if this represent a plane means you will have this equation, right? Ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy plus c is equal to 0. Now this will represent a pair of plane. I think there will be no plus c here. There will be no plus c here, right? I think general homo. Just a minute. I think there will be no constant here. Okay, we already use c, right? So we'll use some plus k. Yes. Now, how to find the angle between the two plane, right? So first, what you have to do is find tan theta, right? So you can find angle between them using this formula. So step one is you can find tan theta using the formula 2 times root of f square plus g square plus h square minus c minus ca divided by a plus b plus c. See, ABC you know, FGH you know. You can find tan theta using this formula. Angle between the two planes is cos theta, right? So find from tan theta you can find cos theta, right? So what is cos theta? Uh, so we know secant square theta minus tan square theta is 1. So we have tan square theta is equal to secant square theta is equal to 1 plus tan square theta. Secant square theta is equal to 1 plus tan square theta. From this you can find cos theta, right? Secant theta is square root of 1 plus tan square theta. From this you find cos theta. And then you find theta. Because angle between the two planes is cos inverse of a1 a2 plus b1 b2 and so on, right? This is a procedure to find angle between them. And it will be perpendicular. It will be perpendicular. That is, two planes are perpendicular if a plus b plus c is 0. Just understand these two slides. So if you want to show a general second degree equation represent a pair of plane, the determinant has to be 0. That is, ABC. This is a symmetric matrix. This is symmetric matrix, right? So just write ABC, HHGGFF, right? HHGGFF. Uh, you can also write in this order also. You write in this order, so it will be easy for you to remember. Just for understanding, I'm just switching. We have HGF. So we will have 2H, 2H, XY, G, YZ, 2G, ZX. Just XY, YZ, ZX, HGF. So it will be easy for you to remember. Okay. So we'll move on to, we're going to do problems and then we're going to wind off these planes. Number 25. Prove that the equation, prove that, prove that the equation x square plus 4y square minus z square minus 4xy equal to 0 represent a pair of plane, represent a pair of planes and find angle between them. So they have given the second degree homogeneous equation. You need to show that it is represent a pair of plane and find angle between them. So compare this with the general equation. So we have a is equal to 1, b is equal to 4, c is equal to minus 1, HGF, right? HGF, HGF. So we have 2H to be 4 and 2G is equal to 0, 2F is equal to 0, right? Compare ax square plus by square plus cz square plus 2hxy plus 2fyz, sorry, 2gyz plus 2fzx. So compare this, you will get, you just find all the values of, so h is 2, g is 0, f is 0, ax square plus by square plus cz square, right? Okay. So 2hyz. Now this will represent a pair of plane if the determinant of ABC HGF This you find the determinant of this. Determinant of ABC 1 4 minus 1 2 2 0 0 0 0. To expand this, the determinant is 0, so therefore it represents a pair of plane. So we have shown the first part. Now we need to find an angle between them. So first find tan theta. So to find angle, find tan theta. What is the value? What is the formula for tan theta? We already found, right? We already written down. So 2 times root of f square plus g square plus h square minus ab minus bc minus ca divided by a plus b plus c. This is 2 times root of f square g square h square. So it will be 0 0 4 minus a into b. So a into b is 4 minus b into c is minus 4. So we will have plus 4 minus ca. So we will have plus 1 divided by a plus b plus c 1 plus 4 minus 1. So this will be 2 times 2 root 5 by 4. So root 5 by 2. So root 5 by 2 is the value of tan theta, but cos theta is the angle, right? So we know secant square theta is equal to 1 plus tan square theta, right? Because secant square theta minus tan square theta is 1. So this will be 1 plus tan square theta will be 5 by 4. So 4 plus 5. So 9 by 4 is the value of secant square theta. So that means secant theta will be square root of 9 by 4, which is 3 by 2. So secant theta is 3 by 2. That means cos theta is equal to 2 by 3. So angle between the two planes is cos inverse of 2 by 3. Right? Cos inverse of 2 by 3 is the angle between the plane. It's a very easy concept. So they will give a second degree equation. You just have to show that it is represent a pair of plane. You show determinant is 0 and cos theta is the angle between them. Find cos theta using this concept. Okay, so we'll move on to last problem in planes. This problem 26. So that the equation so that the equation a divided by y minus z plus b divided by z minus x plus c divided by x minus y equal to 0 represents a pair of plane. Represents a pair of plane. See, if you just take LCM, you will have second degree equation, right? Don't think it is not second degree. If you take LCM, you will have a second degree homogeneous equation. So just take LCM. So LCM is x minus y, x minus y, y minus z, z minus x. So we have a into here x minus y is missing, z minus x is missing, plus b into there x minus y, y minus z is missing, and x minus y is there. So we will have y minus z, z minus x whole divided by LCM is x minus y, y minus z, z minus x is equal to 0. So take that to that side. So simplify this, right? So take that side, simplify this to ax square plus by square plus cz square plus 2hf xy plus yz plus zx in that pattern. Okay, I'm not going to do this, right? So you will have a into x minus y, z minus x, b into x minus y, y minus z, c into y minus z, z minus x is equal to 0. Now multiply all this, you will get the equation as ax square plus by square plus cz square plus a minus b minus c, sorry, you will get this as minus a minus b plus c xy plus a minus b minus c yz plus minus a plus b minus c zx equal to 0. This is what you will have after simplification. So a is a, b is b, c is c. This is what xy, yz, zx. So hgf, right? hgf 2h, 2g, 2, sorry, it is f. So 2h gf 2hxy 2gyz. So here also we will write in this pattern only. So to this 2g, 2g, this 2f, right? Just compare this with the general equation. So 2hxy, 2gyz, 2fzx. So from this you find the value of h. So h is minus a minus b plus c divided by 2, and g is a minus b minus c divided by 2, and f is minus a plus b minus c divided by 2. Now you just have to show it represents the pair of plane, right? Now we need to show determinant of a, b, c, right? H, G, F. So H, H, G, G, F, F. This number is 0. What is A? A is A only, right? A is A only. What is H? H is minus A minus B plus C divided by 2. And what is G? G is A minus B minus C by 2. And what is H? H is minus A minus B plus C by 2. B is B. F. So F is minus A plus B minus C divided by 2. And G is A minus B minus C by 2. F is minus A plus B minus C by 2 plus C, right? Now you need to show it is equal to 0, right? I think I have made one mistake. Wait, please wait. Actually, sorry. This is the equation is 2hxy 2fyz plus 2gzx. Sorry, hfg. Right? You just change this to actually we haven't done any problem. We haven't done any mistake in this problem. Uh, yz and zx are 0, right? So therefore g and f are 0. So you just change to 2hxy 2fyz 2gzx, right? Sorry. 2fyz 2gzx plus 2hxy. Yes. That means this will be 2f, this will be 2g. Right? So just change this to 2hxy 2fyz hfg. Right? Change this order. So but g will be f is g is minus a plus b minus a plus b minus a plus b. This is our g, and f is a minus b minus a minus b. Right? Now you need to expand this and you need to show it is equal to 0, right? So don't confuse yourself. Very easy, all are. Just made one mistake. It is 2h 2. Here also you can change this here. So 2hxy 2fyz 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 2gzx, right? Sorry. Okay. Now you just make use of the operation r1 is equal to r1 plus r2 plus r3, right? If you make this row operation r1 plus r2 plus r3, so you will have 2a minus a will be 0, minus b plus b will be 0, c minus c will be 0, and similarly r1 plus r2 plus r3 will give you 0. Right? So this will be equal to 0 because the first row is 0. So therefore it represents a pair of planes. Very easy. Only thing is you just remember this equation. That is ax square plus by plus c square 2hxy plus 2fyz plus 2gzx. If you want to show it is if you want to show it is represents a paraplane, you just show ABC, HH, GG, FF is 0, and and if you want to find angle between them, use this. I have given you an example how to find. So here 2H is 2G and 2F are 0. So you know all these values, substitute here, and to find angle between them, use this formula. And similarly, this represents a paraplane. To find the coefficients of A, B, C, F, G, H, substitute back here and use the row operation. You will get this is equal to 0, right? You can either use C1 plus C2 plus C3 or R1 plus R2 plus R3. R1 plus R2 plus R3 will also be 0. C1 plus C2 plus C3 is also 0, right? I'm using R1 plus R2 plus R3, which is R1. So R1 plus R2 plus R3 or C1 plus C2 plus C3. You can use any operation, that will be 0, right? So that's it. So we have completed planes. I will share some practice questions and previous year's questions on direction ratio, direction cosine, and the planes. Um, you can make use of it and do practice, right? In planes, we have started with defining planes and the equation of plane in normal form, general form, and the equation of plane passing through a point perpendicular to some line with direction ratio and many more, right? And angle between the planes, we have solved many problems. And in today's class, we have discussed what is the equation of planes bisecting the angle between the two planes, and what is the condition for a second degree homogeneous equation to be will represent a pair of plane, right? This is a condition, and to find angle between them you need to make use of this concept, right? So the next class we will be starting straight lines. So we'll see in the next class. Thank you. All the best.